The compensation method we introduced today utilizing a jig is the most accurate and efficient method that does not require a patient visit.
Hello everyone, thank you for joining us today. My name is Jenny. I'm a part of the education team at Medit. Nice to meet everyone. Today we have Dr. Kim, who is a master in digital workflow, especially with Medit apps and everything about prosthetic work. Thank you for being here, Dr. Kim.
Hi Jenny and welcome everyone. Oh, it's new style.
Right.
Yeah, it is such a pleasure to be here again. I hope today's webinar to be very helpful for you all.
Yeah, today's topic seems very interesting and helpful for those who are doing implant treatment, especially with custom abutment. So today's topic is one-step implant crown restoration with custom abutment. So doctor, can you tell us some contents that you're going to discuss with us today?
Yes, of course. I'm sure so many dentists have concern about perfect fit of crown, especially with custom abutment. So I'm going to focus on compensating the errors of custom abutment fitness that comes from processing. I've tried several experiments to overcome these processing errors of custom abutment, and I got the idea. So I'm so willing to share the tips with you today.
All right, so as always, right after the lecture is done, we are going to have Q&A session. So we've already collected all the questions through the email in advance, but because this is pre-recorded, so we will cover those questions today. And while watching the webinars, if you have any questions, then simply go to the chat box and write down. Then we will reply back with your registered email. And for more feedbacks, or if you have any further questions, then you can send us on any email to meditedu@medit.com. And for more clinical videos, you can visit our YouTube channel. And we have an official training platform just here. Then you can, right. So you can watch the videos according to the curriculums, and you can obtain the summarized text files. And the amazing thing is that it's all for free. So you can utilize our Medit platform to enhance your knowledge regarding digital dentistry. Okay, that's all about it. Shall we begin, doctor?
In this lecture, we will compare different methods of compensating for machining errors on a custom abutment. We will cover the following topics. We will discuss how custom abutments are machined, look at the causes and solutions to machining errors, and compare different methods of compensating for unresolved errors and their consequences. In particular, the key objective of this lecture is to introduce a new method of compensating that is both simpler and more accurate. Let's take a quick look at pre-mill and CNC machining of a custom abutment. The direction of machining affects the outcome. Forward machining will directly connect the blank without using a jig. The advantage is that the connection is strong and the machining error is small. However, after machining, a rest is left on the occlusal side, which requires additional manual removal. Therefore, the more complex the occlusal design, the more disadvantageous it is. Reverse machining connects the blank through a reverse jig so that at the end of machining, the intact abutment can be completed without further machining. However, the connection is weak and is likely to deform during machining. This is a video of blank being processed by connecting it to a reverse jig. The pressure generated during machining can cause deformation in the weak reverse jig area. The machining speed and wear of the tool and jig must be well managed. This is a video of machining a custom abutment using a CNC machine. The process consists of roughing, rest machining, and finishing. Roughing is the process of quickly removing material with a large tool while leaving adequate allowance. Wet machining is the process of removing narrow barrier that the large tool failed to remove before finishing with a small tool to increase tool life and removal efficiency. Finishing is the process of creating the smooth surface of the prosthesis. Now let's have a look at the abutment machined by both methods and discuss the causes of error and solutions. We can see that both machining methods have an error of about 20 to 30 micrometer. This is good enough for clinical use. Let's zoom in on the connection error. We can see that the CNC machining error is over 50 micrometer. A blank is called a pre-mill. It seems to strongly imply that the connection and screw hole are pre-machined. This is why the connections are more precisely machined than with the CNC. This is often the first reason for preferring a pre-mill. Let's leave the connections out and just align the upper part for comparison. The concave in the chamfer margin, indicated by the red arrow, must be designed considering the size of the machining tool. The shape error indicated by the black arrow is common in blank machining. This is caused by under-machining the concave side of the abutment. In CNC machining, the orange area is an error caused by manually removing the little bit left after the connection is removed. Proper setting of the tool can reduce errors. Typically, the thinnest tool for processing custom abutment is 1.5 mm in diameter. Setting it to 1.7 mm with about 15% allowance can avoid the problem of under-machining. Abutment design with blank machining is not good for concave areas. In particular, retention groove is not recommended not only because they are not machined accurately, but also because the inside of the zirconia crown is not machined properly. These offsets are common in blank machining results. It's a problem caused by the misalignment of coordinates when machining upside down, and it must be solved by calibrating the machine. If you're using a jig to machine multiple blanks simultaneously, you will need to measure the position of each blank to resolve the error. Here we will show the error that causes the abutment to bend sideways relative to the connection during machining. The machining error of the blank is quite large at around 200 micrometer. It is thought that the weak connection of the reverse jig is deformed due to significant lateral pressure during roughing. To reduce this machining error, it is helpful to reduce the machining speed and manage the removal efficiency of the tool. It is also important to keep the usage period of the reverse jig that hold the blank so that the connections do not become loose. CNC machining error is relatively small at around 50 micrometer, but there is still a one-sided error. My opinion on this issue is that the CNC machining of the connection is not precise enough. Here's an example. On the left is the design file, and on the right is the scan data of patient intraoral connection. Let's align the two files based on the remaining teeth and compare the difference between the design and the machined abutment. This way, we can see the error in the machining of the abutment. The cross-section shows a lateral error of about 200 micrometer. It would be good to refer to the machining video while listening. The blank is positioned like this and machine starts sideways. If the machining speed is fast or the machining efficiency of the tool decreases, the lateral pressure on the blank increases and may be pushed to the opposite side. This can happen more easily with a reverse jig due to the weak connection. To maintain removal efficiency, you need to maintain the blade of your machining tool. I was able to observe the damaged connection on the reverse jig used on the microscope. Reverse jigs also need to be maintained properly. From here, we are going to compare the tolerance of the different models we used to correct machining errors. The first is the reference model. For the reference model, we created a plaster model containing 5 implant lab analogs. Then we scanned it with Medit table scanner. The second is an intraoral scan. The reference model was also scanned with a Medit intraoral scanner. We compared the table scanner and intraoral scanner scan results. The error range is within 100 micrometer on both posterior molars and around 50 micrometer for the scan bodies. The third is a replica plaster model. To reduce the error of plaster model making as much as possible, a second model was made by reusing the impression with which the reference model was made. This is comparison of the reference model and the replica model. Errors are rarely found in this part. However, errors in the scan body shows a range of 60 to 100 micrometer, which is larger than that of the intraoral scan. The source of this error is thought to be the accumulation of connect error between the lab analog and the impression cupping when creating the platter model. The final model is a 3D printing model. When creating a 3D printing model, there are many factors that can cause errors. As a side note, I had a researcher in my lab who specialized in 3D printing only. When looking at the result, it would be helpful to understand that the results are more controlled than typical 3D printing results. We connected lab analogs dedicated for the 3D printing model and scanned it. You can see that the 3D printing model itself has a very large error. The error of the scan body does not exceed 100 micrometer vertically, but it seems to exceed 200 micrometer laterally. Let's look at the overall comparison. The intraoral scan has a slight scan error, but shows the lowest level of scan body error, as there is only the error of connecting the scan body once. For the plaster model, we used the same impression to reduce the error of the impression, so the plaster model itself had the lowest error. But as a result of the additional error introduced by the new connection, the scan body connection error exceeded 100 micrometer. The 3D printing model was found to be clinically unusable due to the error in the model itself and the large connection error with the lab analog. Summarizing the above result, we can conclude that a model-free compensation method would be the best way to go. Now we will compare compensation method using the model above. The first method is to reacquire the impression by placing a fabricated abutment in the mouth to compensate for the error. In this experiment, the abutment was attached to model number 1 and a table scan was performed on behalf of the patient. We compared the design file with the actual fabricated abutment. It was found that the abutment machining error was over 200 micrometer laterally. The second method is to compensate for the error by attaching the abutment to the plaster model. In this experiment, we connected the abutment to model number 2 and scanned it. This is a comparison between model number 1 and model number 2. You can see the orange color indicating 80 micrometer error in the abutment. This is the same result as the previous scan body comparison. The third compensation method uses a 3D printing model as an alternative to the lack of impression obtained by an intraoral scanner. The dark red and blue colors representing over 200 micrometers are observed in the abutment. The error in the model itself is also large, so it is not advisable to use it in a large model like this. Let's compare the error just in the abutment area. The plaster model has an error of about 80 micrometer. The 3D printing model shows an error of over 200 micrometer. In the end, the best solution is to get additional intraoral scans or impression in the patient mouth. It seems that the plaster model with a generous inner gap of about 100 micrometer or dividing the prosthesis into several parts to reduce the number of abutments and the length of the prosthesis, and staggering the publication would have achieved a more perfect publication. It is difficult to find a reason to use a 3D printing model. I will show you how to do an intraoral scan effectively. When scans or impressions are taken after an abutment has been placed intraorally using a two-stage method, the subgingival margin can be difficult to reproduce. This can be solved by aligning the pre-scanned abutment to the scan file and substituting it. This method is automated in the Medit scan software. Finally, we'd like to introduce a new compensation method. Honestly, it's so simple that I was embarrassed to introduce only this, so I did the before experiment to fill the time. Prepare a jig by planting a lab analog into a mold of a certain shape. Attach a scan body to this jig to scan and save it. Every time I machine another point, I connect it to the jig, scan it, align it with the jig, and prepare the complex. On the left is a video of an intraoral scan with the jig held by hand. The video on the right shows the jig on the turntable, which makes it easier to scan. Of course, you can also scan with a table scanner. The table scanner is useful for doing multiple scans at the same time. Combine the two files using either automatic alignment or alignment based on the jig. Align the scan body of the combined complex to the scan body of the model, and the machined abutment will be aligned accordingly. If you erase the scan body of the model and merge it with the abutment, you will have a virtual compensated model. Here's a comparison of the reference model and the compensated model using the jig. Note that the abutment is colored mostly green. This means an error range of 40 micrometers or less. Let's compare it with the previous method. You can see the smallest error in the compensation method using the jig. Since you don't have to create a model, you can save time and money. Furthermore, by automating this process, it is expected that AI abutment matching shown earlier will be implemented without the patient visiting the clinic. Let's wrap up today's lesson. Custom abutment machining errors can be reduced but not eliminated. Therefore, proper compensation must be made. Such compensation is clinically acceptable for the traditional plaster models, but not for 3D printing models. The compensation method we introduced today utilizing a jig is the most accurate and efficient method that does not require a patient visit.
Okay, thank you for sharing all your tips with us, Dr. Kim. I'm sure many clinicians got the idea of using that jig to minimize the custom abutment that arises from processing. Now, let's move on to the Q&A session. Question number 1. Do you prefer to use custom abutment than prefabricated abutment? If so, why?
I have been in practice for about 18 years, and for the first 15 years, I only used prefabricated abutment. However, for the past 3 years or so, I have been using custom abutment only. The reason is that I received many questions about the differences between the two abutments during my lectures. So I decided to experience more with custom abutment in my clinic. There are many good advantages to use a custom abutment, but I found it inconvenient to have one more step to check with abutment fitness. However, I consistently try to overcome the fitness issue with many different ways. I was able to find the solution that I shared in today's lecture. Even now, I'm using custom abutments only.
Thank you for answering that. Question number 2. Between the modelless way and the model way treatment, which treatment approach do you prefer?
I prefer model treatment with the method that I had introduced in today's lecture.
Okay, question number 3. Do you rescan after connecting custom abutment into patient's mouth?
I had the same answer just as the second question. Since I do model treatment, I can overcome the fitness error prior to a patient visit. Using a jig is the solution.
I see. Question number 4. How do you scan the shiny surface, such as abutment?
I make the abutment ready with surface treated. The upper part of the body is sandblasted and the lower part of the body is polished. Actually, it isn't hard to scan because I scan the abutment separately outside of the oral cavity and make it aligned later on. In a case when there is a shiny surface, I recommend you to use a scan spray.
Okay, thank you for answering all the questions today. Okay, that's all about it for today. You'll be able to watch this webinar on our YouTube channel and Medit Academy. And we would appreciate your feedback. And if you have any questions, then contact us meditedu@medit.com. Thank you for being here, Dr. Kim.
Thanks everyone for joining us today. I will come back with more interesting and useful topics next time. See you in the next webinar. Bye.
Bye.